Alrighty, let's take a look at solving this trig equation here. We're going to want to isolate the trig function, so I'm going to start by adding 9 to both sides of the equation. And once we do that, we're going to have this new equation of 3 times tangent squared of theta is equal to 9. And then similarly, we're going to go ahead and divide both sides by 3. Once we do that, we get this equation of tangent squared of theta is equal to 3. Now, remember that even though the squared is written over here, that this really does mean tangent of theta times tangent of theta, or tangent of theta squared. And if you already knew that, no worries, it's just something that used to confuse me a little bit. And of course, these are both still equal to 3. Next, we will go ahead and take the square root of both sides of this equation. And in doing so, we find out that tangent of theta is going to be equal to the plus or minus square root of 3. Writing this as two separate equations, we have tangent of theta is equal to the positive square root of 3. I'm going to put that plus sign just to make it super clear. And tangent of theta is equal to the negative square root of 3. That means for the case on the left, theta would be equal to the inverse tangent or arctangent of the square root of 3. And in the case on the right, theta would be equal to the arctangent of the negative square root of 3. Now let's see if we can find out when this occurs. Now remember our special 30, 60, 90 triangle where we have the ratios of 1 to root 3 to 2. Those are going to be the 3 side lengths of that right triangle, and that can help us with maybe identifying which angle measure will get us this root 3. If we take a look at taking the tangent of the 60 degrees, remember that if we take tangent, that's going to be the opposite over the adjacent, also known as the y value over the x value. So if we take tangent of 60, we're going to get that root 3, or a positive root 3. Now, if we take a look at this on a coordinate plane, and this is going to be 0 degrees, 90, and 180, and 270. I'm just going to do things in degrees here, and I'll convert things to radians afterwards, just because I'm more comfortable in degrees. And let's see if we can find where these reference triangles are. So try to remember the signs of each of these quadrants. So all trig functions are going to be positive over here in quadrant 1, only sines positive in quadrant 2. And then we have AST, so tangents positive in quadrant 3, and then cosines positive in quadrant 4. So when are we going to get this positive root 3? We'll get this positive root 3 when we have this 60-degree reference triangle or reference angle in quadrant 1. So this is going to be that 60 degrees. Hopefully that makes sense because we're going to have that positive root 3 right over here. That's positive, and then we have a positive 1, so that's the opposite and adjacent, or x, the y and x value, right? And so when is that also going to occur? Well, we're going to get a positive tangent value also when we are in quadrant 3. So I draw a 60, 30, 60, 90 triangle over here in quadrant 3. We're going to get the same idea here, except keep in mind that the opposite is going to be negative root 3, right? Because it's going down, and the x value is going to be a negative 1. So regardless if you're doing the y value over the x value in quadrant 1, tangent of 60 in quadrant 1, that's going to be positive root 3 over 1, which is positive root 3. Or you go ahead and do it in quadrant 3, which is going to be negative root 3 over negative 1, that's still going to be a positive. You're still going to get positive root 3 as the ratio. So we're going to get two angle measures here. So in terms of the case where we're talking about arctangent equaling this positive root 3, we have two angle measures that we can really look at here. So one of the angle measures I'm going to write up here at the very top. We're going to say that theta could equal, well, 60 degrees, that's for sure, in quadrant 1. And let's see, how do we identify what this other angle measure is? So from here to here, it's definitely 60 degrees. But what's the angle from here all the way down to here? Well, I think that's just 180 degrees more, right? So if we add 180 to that, that looks like it is 240 degrees. And that makes sense because 240 is in quadrant 3. But is it going to keep occurring? I think so, right? If we add another 180 to that, we're going to end up back at the same location here. So if we add another 180 to that 240, I think that's going to be 420 degrees. Right? 420 degrees. Again, that's the same location as 60 degrees. And if we just keep on adding 180 over and over again, we're going to keep landing right on top of these reference triangles just in quadrant 1 and quadrant 3 over and over again forever. So if I add another 180 to this, that is going to be 600 degrees. Right? So this is going to go on forever. So we can say this is going to be plus 180, and we can use times n or times k, however you want to think about it. But this is going to keep on going forever and ever, right? If we go ahead and convert these to radians, we can say that 60 degrees is just pi over 3, all right? And then we're adding basically 180 over and over again, so that's just going to be pi. So I'm going to say plus pi times n. Some people say pi times k, but n or k just represents how many times we're going around. So this would just represent the infinite number of angle measures that still gets you these 60 degrees reference angles. All right, so we just figured out how to find out the angle measures that give us this positive root 3. So let's see what angle measures will help us get this negative root 3 for the ratio. Now, if we think about it, we know that tangent is going to be positive in quadrants 1 and 3, so it must be negative in quadrants 2 and 4. So let's see what happens if we draw this 60 degree reference angle and draw this 30, 60, 90 triangle over in quadrant 2. Again, that's a 60 degree reference angle right over here. And if we go ahead and write the ratios down, going to the left, that is -1. I'm just going to leave that, but it's going up, so it's positive root 3, and the hypotenuse is still going to be 2. If I do tangent of this 60 degrees in quadrant 2, this is going to be opposite over adjacent, right? Or y over x, and that's going to be negative root 3. So that seems to be doing the trick. And then let's go ahead and see about another location. Let's go ahead and check out quadrant 4. Go see quadrant 4 here. If we do a 60 degree angle over in quadrant 4, and then write in these ratios, we do have 1 going across. We have negative root 3 because it's going down for the y value, and the hypotenuse is 2. And if we do tangent of the 60 degrees down here, what we will get is the opposite over the adjacent, or the y over the x, and that's also going to be negative root 3. Now, if we're going to go ahead and try and write these angle measures for this first angle, I know it's a 60 degree reference angle, but really what is that location? That is going to be, I think, 120 degrees, right? So for this first angle, I'm going to say theta is going to equal 120 degrees. That's going to be that 60 degree reference angle in quadrant 2, right? And then to get to the next one, let's see how that's related to that. Well, if you go down 180 degrees, notice how it's a straight line going down across. And so if you add 180 onto that, we're going to actually end up with 300 degrees, which makes sense, right? Because 60 degrees in quadrant 4, if it's 60 away from 360, then 360 minus 60 is just 300. And if you keep going around and around and you keep adding, so if you add another 180, we're going to get back into quadrant 2 again. So if you add another 180, that's going to be 480 degrees. And you're going to notice that you can keep going round and round. And if you keep adding multiples of 180, you're going to keep getting this whole pattern going back and forth into quadrant 2, then 4, then 2, then 4. And I know I'm not really writing this perfectly. I'm writing 180n, but I'm hopefully just trying to convey that it's just adding multiples of 180. So I probably could have written that a little bit better. I guess the more precise way to say this is theta is equal to, if 60 degrees is pi over 3, then 120 should be 2 pi over 3. It's just double that, right? And then we're going to add pi n, or multiples of 180 degrees. So basically this 120 degrees and then adding 180 onto it over and over again will get you this negative root 3 as the ratio. So there you have it. Basically, we went ahead and found out that 60 degrees was the important angle that we needed to go ahead and find out the ratio of this root 3. And since we knew it could be positive root 3 or negative root 3, we had to check other quadrants as well. So it turns out when we were in quadrants 1 and 3, we would get a positive root 3 for the ratio, which is where this angle measure of 60 and 240, or this pi over 3 and the 4 pi over 3. And so that's going to be these blue triangles here. And then over here, the purple triangles, they were also 60 degree reference angles, but these ones helped us get the negative root 3 ratios because tangent is negative in quadrants 2 and 4. So hopefully you found this helpful. And as always, keep up the great work.